Well, good morning there, ladies and gentlemen. Let's use this good old-fashioned Dixon Ticonderoga number 2, hashtag not sponsored, here's what we're going to do. We're going to graph this. This is what's coming up next. So I know we've been doing distance learning, and I know that's tough. Like, you guys are doing a great job, and, man, it's a tough situation. You guys are making the most of it. So we're going to pull all of those things together that we've learned here with this. And so what's going to end up happening, I think, is some of the things that have been confusing are going to come out in this. And that's actually a good thing because that's how we're going to learn them, right? So here's what we're going to do. We're going to make a graph of this. And this is what we're going to be learning how to do basically until, well, through the end of the quarter, right? So look, one of the things I always do is I make a little box of all of the information that I need to collect. So when I'm going to make a graph is a picture of all of the answers, right? So on a curve, like this is going to be some kind of curve, right? It's going to be some kind of curve, might look something like this, I don't know. And that's going to be on a coordinate plane, right? Well, every little point is a coordinate, x comma y, and every one of those points will be a solution that if I plugged the number in for x, and I did the math, what it would equal would be that y. And that's true for every point on the graph. But a point not on the graph, like this, would not work. What I mean is, if I took that number for x and plugged it in and did the math, it would not, the answer would not be this y. So every single dot on the curve is a solution, meaning that you can plug x in and you get the output that's y, right? And we don't want to find all of the points, so what we do instead is we find some key ideas. Like we look at the end behavior, we look at the x and the y intercepts, we look at the number of turning points, all those kinds of things, right? So what I think we should do, this is the way I've done it. Once I learned how to do this, it just made life so much easier for me. So we need to look at the end behavior, which to figure that out, we have to know what the degree is, right? So we have to look at the x and the y intercepts, number of turning points, all of that kind of thing. So yeah, so let's do it, shall we? So check this out. First thing we're going to do is we're going to find the degree. So we are going to be multiplying these three things together. When I multiply x times x squared minus 9, I get x cubed and some other stuff. But the other stuff doesn't matter because x cubed is going to be the biggest exponent out of multiplying this times this. Okay? So that's going to give us x cubed and it's going to be minus 9x, right? But x cubed. When I multiply x cubed times all of this, the biggest exponent is going to be x cubed times x squared, which is x to the 5th. So my degree is 5. That means I have a maximum number of turning points that's 4. Do you see? Okay, so the degree is 5. Since the degree is 5, it's either going to look this way, down, left, up, right, or the other way. And the way I know the difference is if the leading coefficient is positive or if the leading coefficient is negative. Well, when I multiply x times x squared, that's a positive 1. So that means it's going to look like the end behavior is going to be like this. It's going to be down, left, and upright. What happens in the middle? I don't really know. That's what we got to find out. So to do that, let's start figuring out the x and y intercepts. Let's find the y-intercept first. That's the easiest one to do. The way you find the y-intercept is you plug a 0 in for x. So we're going to do that right here. Plugging in a 0. You see? And so here's the deal. It doesn't even matter. If this first number is 0 and it's all multiplication, it doesn't matter what that number is. It's a big number, but who cares? It's times 0, so it's 0. So it's going to go through the origin. And that's actually one of our x-intercepts because, look, on this little coordinate plane right here, an intercept is where the graph crosses the x-intercept or the y-intercept. If the y-intercept is at 0, 0, the origin, then that means it's also an x-intercept. So that kind of gives us that nice one right there. All right, now, to find the x-intercepts, what you do is you take the whole function, you set it equal to 0. So 0 equals x squared minus 9, and then the rest of that hotness right there, right? Okay, you're going to factor it. Luckily, this one's already factored. And then you take each factor and set each factor equal to 0. And the reason we do that is because this is a number right here times another number times another number. So if you have three numbers, A and B and C, if you have three numbers and they're multiplying and the answer is 0, then either this equals 0 or that equals 0 or that equals 0 or any combination thereof. So that's why we're trying to figure out what values of x would make each of these equal to 0. Well, this one's already solved, right? So we already knew that. We had 0, 0. This one, it's going to be plus and minus 3. You can factor it and solve it, or you can just use inverse operations. There's only one x. If you have an x squared and an x, you can't use inverse operations to solve it. You're going to have to do factoring or quadratic formula. But here, we could add 9, right? And then you take the square root. The square root of 9 is 3 and negative 3. Negative 3 and 3. And you need both. Very, very important. Muy importante. That's a Cal's favorite word in math. Muy. But you need both, right? 3 and negative 3. And then this one, it's factorable. It's x plus 6, x minus 4. Take each of those, set them equal to 0. You get x equals negative 6. You get x equals positive 4. So negative 6, 0, and 4, 0. So those are our x-intercepts. 1, 2, 3, 4, 5. We have 5, which we know is the maximum number of x-intercepts that we're going to have for a degree of 5. Okay, so let's go ahead and sketch a graph right here. All right, so check this out. Man, that's a nice looking coordinate plane. So x here, y there, right? Here's what we know. We know that we have 5 x-intercepts. So let's go ahead and just do a little sketch. All right, now we know that we have an x-intercept at the origin. And you got to sharpen the Dixon Ticonderoga. Oh man, what a nice pencil. Man, these things have all the answers. 6, negative 3, positive 3, positive 4. Those are our x-intercepts, right? 0, 0, negative 3, positive 3, negative 6, positive 4. Now we know the end behavior is down left. So that means from here it's going to be going down and up right. So from there it's going to be going up. Now we don't know what happens in between. We don't really know. Now we do know that the maximum number of turning points is going to be 4. So it could not be something like this. It couldn't be. That's 1, 2, 3, 4, 5, 6, 7, 8 turning points. That's impossible. For a degree of 5, the maximum number of turning points is going to be 1 less. So the most turning points we're going to have is 4. So we cannot have 5 turning, or more than 4 turning points. But to figure out what's going to happen is, here's what we're going to do. Check this out. We don't know. This is going to be really important. This is kind of the new idea. This is new information. So check this out. We do not know if from here, if the graph goes up or if it turns and goes down. We have no idea. It could do either one. But here's the thing. If it turns and goes down, then over here, the y-coordinates are going to be like right here, that's negative 5, right? Negative 5, comma, a negative number. Whereas if it went up, like right here, it would be negative 5, comma, a positive number. Do you see? And so what we can do is we can actually take negative 5, we can do f of negative 5, and we can see if it's positive, or we could plug in negative 5 and see if it's negative. Because if it's positive, then that means from here it's going to go up. Whereas if the negative 5 had a negative output, then it's going to turn around and go down. So here's how we do that. Check this out. This might seem like a lot of work, but it's going to turn out to be really, really, really easy. I promise. Here's what we got. Here's our function right here, right? So all you need to do is look at the sign. You don't actually even need to do much of the math. All you need is the sign. Okay. So here's what we're doing this right here, right? Here's what I'm looking at. That's a negative number, negative 5. This is a positive number, right? This is a negative number. So a negative times a negative is positive, times another positive is positive. It's going to go up. Do you see how we did that? Let me recap. Ready? Recap. Not cap, no cap, no cap, no cap. Just recap. No cap, recap. All right, so look. Here's the deal. Here's what we found out. We found out that at negative 5, when I plug negative 5 into the graph, what I have is a positive number. So it's going to go up. I don't know how far it's going to go up. I don't know where the turning point's going to be. And until we learn calculus, we cannot find the turning point accurately. All I do know is it's going to go up from there, and it's going to come back down and hit there. That's all we know for sure. It's probably going to look a little prettier than that, but you got the idea. So the reason I know it goes up is because I plugged in a number in between here and here. I'm going to do the same thing between here and here. I'm going to plug in negative 1. Negative 1's an easy number to plug in, right? So we're going to get negative 1 Negative 1 squared minus 9 is negative 8. And then negative 1, oops, so I'm plugging it in here, right? So negative 1 squared is 1. Minus 2 minus 24. So this is a negative times a negative times a negative. A negative times a negative times a negative gives me a negative number. That means it's going to go down. From here, it could turn back up or it could go down. I'm going to go down to there. All right, now check this out. We could do the same thing. We could plug in a 1, and then we could plug in like a 3.5. But well, let's just do it. Let's just plug in a 1 and see. We have 1 times negative 8 again, and then times 1 plus 2 minus 24. So that's a positive times a negative times a negative. It's a positive times a negative times a negative. That's positive. So it's going to go back up again. We don't know how high. All right, now, check this out. We have 1 turning point, 2 turning points, 3 turning points. Do you see? The maximum we can have is 4. So if we went down, that would be 4 turning points. If it turned around and went up and did that, that would be 3. We already have 3. That would be 4, 5, 6. So that's impossible. That's the most number of turning points we can have for a degree of 5 is this hotness right here. Okay? So our graph's going to look something like that. I don't know how far down it goes here. I don't know how high it goes up there. Same here. No clue. But that's going to be a good sketch. Now, if you haven't done so already, I'm going to highly advise that you get the app Desmos. It's your buddy. I got a jacked up phone, but you got the idea. So here's what we're going to do. I'm going to use Desmos to plug in this function. I'm going to just check to see if I've got the general idea correct. So it's x parentheses, x squared, x squared, I think minus is there, minus 9, close parentheses, x squared, plus, nope, plus, there we go, 2x minus 24. Oh man, look at that. So let's zoom out. Oh man, that's so funky looking. Here's what we're going to do. I'm going to change my grid. I know that the x-axis doesn't need to be that big, so it needs to be from like negative, let's do negative 8 to 6, and then let's do this from negative, let's say 600, I don't really know how far down it needs to go, and then let's say to positive, let's say 1,000, I have no idea. That should give us a view. Ah, there we go. Look at that. So that's our graph. Let's see how we did. So look, down left, up right, we had an x-intercept right here at 6. It goes up, and then down, and then up. Ah, look. How did we do? Looks pretty similar. So you can use Desmos to help you check. And hopefully you don't have like a busted old phone where you can't see if it's plus or minus. Anyway, that's what we're going to be working on. And it's going to take a little while. So we're going to have to be really patient with these. And I'm going to post some notes and things like that you can kind of walk through step by step like I just did here. And we're going to go from there. So anyway, I hope this has been helpful. I know it's going to be a little confusing right now. That's okay. Here's what I think you should do. Here's what I'd like you to do. I just walked through this whole thing on my own. What I would like you to do is, if you didn't take notes, take notes. Okay? So rewind the video, watch it again, take notes. And then give it a little while, just a little bit of time. And then try it on your own. Don't try to remember exactly what I did. Remember the ideas that we used to make the graph for that function. And then try it. I think that's going to be the best way you're going to be able to learn this, especially in a remote setting. In person, that's what we'd be doing. So anyway, hope it's been helpful, and you guys are absolutely wonderful. Hope you're having a great day, and be safe. I'll talk to you soon.